Hi everyone, this video is going to help with 11.6 optimization. And the idea for optimization is still using all of those graphing methods, but like for what type of business problems or what type of problems in the real world use this idea? So all of your problems are different, and it can be a little bit harder because they're all word problems. Hang in there. Let me know if you have questions, and you can always do the ask the instructor and send me the problem, and then write what you have questions about. So the procedures that it gives you from the book are to introduce your variables and to decide if you're looking for a max or a min, and kind of like read the problem twice, figure out what it's asking. Part 2 says find your critical values. Those will tell us, right, where a max or a min might be, especially an absolute max, right, or absolute min. Use the procedures from the absolute max min section, and you can use the idea of the second derivative being bigger than 0 or the second derivative being less than 0. That can help you as well with if it's in a max or a min. Okay, so maybe I'll write that on here because we had if the second derivative is greater than 0, then we said absolute min. And if the second derivative was less than 0, so if it's negative, we said it was an absolute max. Maybe I should have wrote the word absolute. We write the word absolute on there maybe too. Absolute. So we double checked those minimums and maximums with a second derivative. Another way to double check would be on a graphing calculator. That is another way. Okay. Okay. Use the solution to the mathematical model to answer the questions asked. So it's always like, okay, you found all this stuff. Now go back and see what it's actually asking in the problem. So let's look at the first type of problem we have with this. Find two numbers whose sum is 50 and whose product is the maximum. So we're looking for a maximum, and we have two numbers. So let's start by labeling our numbers X and Y. Okay, so then we say their sum is 50, so we can label that as X and Y have to add to 50, and their product is the maximum. So the way that I like to write it is just to think it out as X times Y has to equal my max. And then my idea is I want to manipulate my first equation to go into my second one, so I only have one variable, and then I look for the max of that function. So I'm going to solve for y up here. So y will equal 50 minus x. Okay, and then I can substitute that in to my max function here. So now my max function will be x times 50 minus x equals the max. So I'm going to simplify that, and I just have 50x minus x squared equals the max. We can call this the function, okay, that we want to find the max of. You can keep calling it the max. It doesn't matter. Then from here, we have to take the derivative and see where our critical values are for what's going to be our max or min. So derivative is going to be 50 minus 2x equals that derivative. And where does that equal 0? Will give us 20, will give us that critical value. So minus your 50 over, divide by -2, and I get a positive 25. So I bet that's our answer, right? Like positive 25. Okay, so then from there, if x is 25, we know they have to add to 50 in order to get that y. So y would be 25 as well. Okay, so how could we double check that that's an absolute max? Well, we could take the derivative of the derivative. Remember, that's our second derivative. We could also graph it. That would be a way as well. So we could take that second derivative of this one's fairly easy. So I'm going to do that. second derivative of this derivative is -2. So it is definitely less than 0. So it is our absolute max. It didn't matter. We didn't have an x to put the number in. The answer is just -2. So it's definitely our absolute max. And we could see this as an x squared. So it would have an absolute max or absolute min, definitely. Okay. So these would be our x and y. So if we answer the question, it says find the two numbers. The two numbers are 25 and 25. Their sum is 50 and their product is the max. It could ask you what the product is, which would be just timesing the 25 and 25. They just happen to be the same number. They aren't always on the problems that you guys do. So 625 is the product of 25 times 25, according to my cheat sheet over here. Yeah. So it might ask the 625 as well. So you'll be putting in the 25 and 25 for the two sides. Okay. So you might see a problem like that. Now, have you done that type of problem before? Yeah. Not with derivatives, but you've definitely done something like that before. It's in Math 1400 or the college algebra type courses. A fence is to be built to enclose a rectangular area of 900 square feet. The fence along three sides is to be made of material that's $14. The material for the fourth side is more expensive, like you want your front to be prettier. And that's $42 per foot. Per linear foot, right? Per foot. Find the dimensions of the rectangle that will allow for the most economically built fence. All right, let's draw this. We know that three of the sides will be $14. And one side will be expensive at $42. And we also know the area, which we know is length times width, is 900. That was given to us, square feet. So we know that there's 900 square feet in there. Okay. That's all we really know. We can think of what would be the perimeter. So if I call this well, it doesn't matter. I can call this the length and that the width, right? And then you have two L's and two W's. So I could think of the perimeter is going to be with the cost, and the cost is what I want to minimize. Because the perimeter has to do with your cost, not the area. The area is going to help us solve that perimeter problem, but the perimeter would be 14W plus 14W plus 42Ys plus 14Ys. Oh, I changed it from whatever. Lengths. I wrote X's and Y's on my paper that I was looking at. That's why. And we don't know what this is. This is our min. So I thought through, I need to minimize a perimeter. That's what's going to catch you, making sure you know which formula you want to write the minimize function on. And then we could reduce this because we can add the W's and the L's. So I really have 28 W's plus 56 lengths equals the minimum. Now I don't want two letters, but I have to use that information of the length and width area being 900 and substitute that in here. So either one that you want to solve for up here, you could think of dividing the other one over. So I don't know that it matters, but let's just divide by the length. That's fine. And then the width is going to equal 900 divided by L. So the width is now going to be 900 divided by the length. And then you have plus 56 lengths equals minimum. Okay, let's keep going. I'm going to simplify that for sure because my minimum is also my function that I want to take the derivative of. So I want to simplify as much as I can. So what is 28 times 900? It is going to give me 25,200 over L plus 56 L's equals that function. Now let's take the derivative of this. And when I do, the easiest thing was to bring this L up because it's not under everything. I don't have to use the quotient rule, but you could because the derivative of a number is 0. So you could use the quotient rule. You just have some zeros in there that makes it work out. But I kind of like the thought that it is written like this. When there's just one, a negative exponent is way easier to work with to me than doing the full quotient rule. So I would just bring the negative one out front. So negative 25200 L to the now negative 2, because negative 1 minus 1 more. Derivative of 56L is just 56 equals the derivative overall. And then where does this equal 0? So I could think, all right, so if I go to write this, where's it equal 0? I'm going to think of this 200, I over L squared plus the 56. We're here, right? So I'll minus the 56 over. I like how I use two different 2's. I do it all the time. Okay, and the same number. Excuse me, I'm sneezing and have a little bit of runny nose here. Okay, so then I'm going to go L squared times the 56. So that's negative 56 L squared equals negative 25200. And that's why I moved the L squared back down to the denominator, is so I could think of moving it over then versus it being a negative exponent. Just a little bit harder to think through when you go to do the problem. So I'm here now. I could easily see I divide by the negatives. So 2 negatives divided is going to be a positive. And I have 200 divided by 56. I sure hope that's pretty. Squared equals 450. I still don't think that's pretty. So the square root of 450 does not look also pretty. 21.2, not pretty. But let's just use the decimal. And why am I only using the positive? Because we know it would have been negative or positive, 21.21. Why am I only using the positive? Can I have a negative perimeter? No, it wouldn't make sense to have a length of a negative. So a lot of times when you're doing problems like these that are realistic, you get to ignore some of your answers. And this is one of those cases. So the length is this, and the width, they have to multiply to 900. So I can find my, because this is my length I found for my critical value. And well, so it's my critical value, but it's also my answer, my length. And hopefully it's a minimum. We'll check that with our second derivative. But we have to put this in 900 divided by 21.21 is about 42.4. So the width is about 42.4. So there's my L and W. Now I still not sure if this is a minimum because we want it to be, right? Because the problem told us. So I'm going to do the second derivative right here. And my second derivative of my derivative is right here. So second derivative would be -2. Ooh, I don't know that. So -2 times -25200 is 50400. L to the -3 now, and then no more. No, I don't need it equals the derivative. I already have that part. So this is my second derivative. Now I have to put in the L I found and see what I get. So I still have the number in my calculator. So I'm going to times that by, what was my L? 21.21 to the -3 power, and I got a +5. So into my second derivative, I put 21.21 and I got a positive 5.3-ish. What does that mean when I get a positive? If we go back to what we wrote on the front, if we get a greater than 0, it is our absolute minimum. Okay, so I could have graphed that as well to find that. So yay, this is our absolute min here. And then it's going to probably ask, it'll say the material for both or find the dimensions, which we did. And the rectangle will allow the most economical fence that we build. So what would be the cost of that fence in case they asked us? That minimum cost is I would go back up to my perimeter and I would have 14 times what was the width? 42. I was like, where did I get that? I see what I did. 42.4 plus the same thing. I did 2 times it instead. So it'd be the 14 times the 42.4 twice 2 widths. And then our lengths would be plus 42 times 21.121 plus 14 times 21.21. So I'm going back to that original. I wrote it a little weird because it's running out of space. And then I'm going to plug that into my calculator, and that will get me my total cost of my fence. So it's $14 times about 42.4 plus $14 times 42.4. I didn't push times. $14 times 42.4 plus 42 times 21.21 plus 14 times 21.21. And I get $2,374.96. So $2,374.96. That's what I get for my total cost of my fence. So you could be asked the total cost, but this was our dimensions. Make sure we always go back to the original for the answering the questions. And it was original to get the width too. So we use the derivative to find information about the original. So we got to remember that always. We don't want to plug it into the derivative. Okay, got 2 more I want to do with you here. Problem 3. So problem 3 says, a commercial apple grower estimates from past records that if 50 trees are planted per acre, then each tree will yield an average of 70 pounds of apples per season. Woof, if for each additional tree planted per acre up to 30, the average yield is reduced by 1 pound. How many trees should be planted per acre to obtain the maximum yield per acre? What is the maximum yield? So this one does say how many trees, and then what is the actual yield? Okay, so let's think about, first of all, the domain of this function is going to be, our number of trees has to be less than or equal to 30 per acre. That does play a role, but like, it's more of like when you look at your answer, you can't have anything above 30. So if we got 2 solutions on our critical value, we would be ignoring one. Okay, so then let's think of trees. So in the past records, there were 50 trees planted per acre, and we're going to add trees. So I think of my trees as 50 plus however many I add. So think of X as our new trees. So X is additional trees. I should say that. So I'm going to write that there for you. Just the new trees that I want to add. So I already have 50 per acre, and then I'm going to add so many. Okay, and then it says that each tree will yield 70 pounds, but we lose 1 pound per tree. So if I think of my yield, right now I get 70 per acre. So these are all, no, that's per tree, right? 70. So this is our number of trees, 70 pounds of apples per season. Yeah, each tree. But I have to subtract off however many new trees, 1 pound. So it's like 1x, £1 per tree. So if I times the number of trees by the number of yield, I'll get my yield of apples. Hopefully that makes sense. I think once you've seen one like this, no matter what they're talking about, you'll have a pretty good sense of what it is. So this is going to equal our total production of apples. And we want this to be maximized. So we've set up our maximize this way. Now, if you could get to the same idea in a different manner, if you think through it differently, great. This is how I thought through it. I'm like, well, number of trees times the yields will give me the total production. Okay, I'm going to multiply this out. So 50 times 70 is 7,500. 50 times negative x is negative 50x. X times 70 is 70x minus x squared. Simplify that out. You could just add those middle terms. Okay, so we know this is definitely going to have an absolute max or mid because it's an x squared. So let's find that derivative. Let's call this our original function here. And let's find the derivative of that. So the 3,500 goes away. I got the 20 left minus 2x. So there's our derivative right here. Where does this equal 0? Going to get our critical value. Minus the 20 over, divide by -2, and I get 10. Is that number less than 30? If I would have got 2 answers, then I would have ignored one if it was greater, or if it would have been negative, that wouldn't have made sense either. So we need 10 more trees. These are additional trees to maximize. We could double check our second derivative is pretty easy. It's a negative. So an absolute max goes with that negative second derivative. So we're good. So this is our absolute max. So we need 10 more trees. So we would have 60 total trees. And how many pounds of apples would we get? So we would have, because we had 50 trees. Yeah, 60 total trees with the 10 extra. And 60 times, so we do 50. I'm going to write it out from the original, plus the 10 times the 70 minus the 10. That's going to equal our production. Just putting that back into our original thing there. I couldn't quite write the word out very well, but so that's 60 times 70 minus that is 60. So I get 36,000. I said that wrong. 3,600 pounds per acre. So 3,600 pounds per acre. All right, there's that type of problem. Last one that I have. So number 4, a 400-room hotel in New York City is filled to capacity every night at $100 per room. For each $2 increase in rent, 4 fewer rooms are rented. If each room costs $12 to service every day, how much should the management charge for each room to maximize its gross profit? What is the max gross profit? To me, like these last 2 problems, if you're in ag business, problem before is more oriented to you. And if you're in traditional business, something like this is going to come up and they're going to expect you to have an idea of how to solve it. And yeah, there are other ways, but derivatives do make it a little easier. So let's think this through. We want profit. So let's just remember that profit is revenue minus cost. Just so we remember, revenue minus cost is that profit. We've used it quite a few times now, so you're getting pretty good at that. So let's think through the revenue is going to equal X times our price. Okay, X is just the number of rooms. Maybe I'll write that up here. So our revenue is always just how many items, which our items are rooms, times the price. That's it. That's our revenue. So for this, our number of rooms would be 400 room hotel minus we would lose 4 people for every, let me read it again. For each $2 increase in rent, so we're going up by $2, we lose 4 rooms. How would we state that? So we're going to think of it as, we're trying to write this X as it's 400 rooms, and we're going to minus 4 times each increment of 2. $400 minus, because the number of rooms, and X is the number of rooms. X has to just be our number of rooms. Yeah, that'll work. I was second guessing myself. I've already done it like 3 times, but I just second guessing myself on the 4X. But that would get us right, because 4 times however many rooms, then we'd minus that off the 400. Okay. And then the cost, the price, is going to be $100, but we might add $2 increments. That's, see, the $2 is included in this part, and it was throwing me for a loop in my brain. So this is your X times your price. This is just your revenue. And let's set up our profit. Okay, so our profit, it had an extra E, is going to be revenue, which we know is 400 minus 4X times 100 plus 2X. And then we're going to subtract cost. So what would be our cost? So I was just looking at revenue. Our cost is $12 per room. We already stated how many rooms by this. Okay, so we're going to do how many? It was $12. Yeah, $12 times 400 minus 4X, because this is your number of rooms. And this would be your cost, price per room, cost. Well, I don't really want to use the word cost because it doesn't, a price per room, price per item, because our cost to the company, it's costing us $12 for each room to service. So can you see how that would equal our profit? This is our revenue because it's just money coming in, but then it's going to cost us $12 per room to service. That seems kind of cheap. They don't pay their maid very much. Okay, and we want to maximize this profit. So we're going to have to simplify this here. So 400 times 100, 400, or 40,000, just 4 times 1, add all the zeros. And then 4 times 2X is an 800X. Negative 4 times 100 is negative 400X. Negative 4 times positive 2 is negative 8X squared. Minus, okay, what is 12 times 400? So 12 times 400. Sorry, I was checking something real quick. 12 times 400 is 4,800. And then, oops, we have to minus this whole thing. So I'm going to still do a negative or a parenthesis here. So that's 4,800. I lost the 8 minus 48X. And then you have to change the signs, right? So this would become negative. This would become positive to make that positive. Then you could see them better. Just make sure you change the sign of the second one because you're minusing the whole cost off. All right. If I simplify this down, I got an X squared here. So I'm going to have negative 8X squared. That one I took care of. And then I have 800 minus 400 is 400. And then I have 48. So 400 plus 48 is 448 X's. And then I would have 40,000 minus 4,800 is a positive 3,000 or 35,200. Yeah. Okay. Ta-da. This is our function, right? That we want to maximize to get our profit there. So we'll take the derivative. I wrote it as a derivative. It's not the derivative yet, but it will be derivative. Okay, so negative 16x and then plus 448, and then everything else drops off. Minus this over when I want to equal it to 0, divide it by the 16, and I get 28. Bet that's our answer. So, all right, so we got 28 rooms. So that's to maximize. Kind of seems weird, but renting not all rooms saves us money. Seems strange, but true. Well, kind of. But still, $12 per room. It is true, though, for this setup. Okay. So if we want to figure out our total rooms, okay, this was our number of rooms. So we would do, this was our number of rooms fewer that we are going to do. So it's 400. Go back to the original. Minus 4 times the 28. And then it will be the price will be the 100 plus $2 times 28. So I get this one to be $156. So I should charge more money and have less rooms to worry about, less people to worry about. And I can't quite fit this one on, but it's 288 rooms. Okay, so our profit would be back up to this profit function, putting everything in. I got $41,472. This was our profit. $41,472. Sorry. So this is kind of tricky. I get that. So do your best. Let me know if you have questions. There isn't very many on your homework, but they're like super important for us to have some kind of idea on where to go when we want to maximize or minimize. So we're typically minimizing our cost and maximizing our profit. All right, or maximizing revenue, but usually we go with profit, just depends. All right, good luck.